Hello, I am Renee Robinson, and I'm going to teach you how to do a limiting reactant stoichiometry problem. I pulled these questions from the Modern Chemistry textbook that you see in the top left-hand corner. I'm going to do number 1A on page 294. The question reads, carbon disulfide burns an oxygen to yield carbon dioxide and sulfur dioxide according to the following chemical equation. If 1 mole of carbon disulfide is combined with 1 mole of oxygen gas, identify the limiting reactant. So this is very similar to any other stoichiometry problem. First thing you always want to do is make sure that your equation is balanced. And if I look here, I have 1 carbon on either side, 2 sulfur. Looks like that with this 2 coefficient here and this 2 coefficient in front of sulfur dioxide, I am already balanced. With that said, when it comes to a limiting reactant, you're really just trying to figure out of the 2 moles of each, or the 2 mole numbers that they give you, one for each of the reactants, you're just trying to figure out which one will produce the least amount of product. Now, if you had an equation that had a 1 to 1 to 1 to 1 ratio in all of them, and obviously if these numbers were a little different, then you could simply look to see which number is smaller. And in this case, the 2 would be smaller, so the carbon disulfide would be the limiting reactant. But our problem given here is not like that. They're not very lucky to get the 1 to 1 to 1 ratio. We have some 2's in there. So with that said, you basically go from moles of a reactant, or both of the reactants, to moles of any product that you want. Now, I like to pick the product that is the easiest to do. And in this case, the 1 that's in front of carbon dioxide seems pretty easy to me. But you could do it with sulfur dioxide and you'd get the same results. But once you go from mole of the reactant to mole of the product, you simply look to see which one, either the 1 mole of carbon disulfide or the 1 mole of oxygen, which one is going to produce the lowest amount of your product. Okay, so let me show you what I mean. And I'll go ahead and do, we'll do moles of CO2 over here is what we're trying to find. And I'll do moles of SO2 over on this side to show you that you're going to get the exact same results. Okay, so we always start off with our what's given to us. And in this case, we're given 1 mole of CS2. And we're also given 1 mole of oxygen. And like I stated here, we're just going to go from moles of our reactant to moles of our product. Very easy, very basic mole to mole stoichiometry problem. Okay, so with moles of carbon disulfide on top there, we need to put moles of carbon disulfide on bottom here. And then we put our moles of what we're trying to find on top, which on this side, we're trying to find CO2. Whenever we do moles over moles, we pull from the balanced chemical equation, and it's 1 and 1. So this one's pretty simple. 1 mole of carbon disulfide produces 1 mole of CO2, which is why I like to always pick the product that has 1. Just makes life so much easier. Alright, on this one, we put mole of oxygen on bottom, and again, mole of CO2 on top, since that's what we're trying to find on this side. Mole of CO2. And mole over mole, we pull from the balanced chemical equation. O2 here has a 2 in front of it, so we're going to put a 2. Oop, battery. And carbon dioxide, it has a 1 in front of it. So 1 divided by 2, you guys can do the math. That's a 1/2 mole of CO2. Now that you have these 2 moles, you simply look to see which one produced the least amount. And in this case, the smallest number is when we used oxygen, the 1 mole of oxygen. So that would mean that oxygen is our limiting reactant. Let's see if we get the same results if we go to moles of sulfur dioxide. So same thing, 1 mole of carbon disulfur, or carbon disulfide, excuse me, mole of carbon disulfide down here. This time we'll put mole of sulfur dioxide on top. And this one's still 1. Carbon disulfide has a 2, so we're going to put 2, so that is 2 moles of sulfur dioxide. And here, same thing, 1 mole of oxygen. It's the other reactant. We put mole of oxygen down here, mole of sulfur dioxide on top, and we pull from the balanced chemical equation 2 and 2. 2 and 2. And that's obviously 1. So you guys can see that you still get the exact same results no matter what product you decide to pick to go from mole of each reactant to mole of whichever product. So you can pick any product, it does not matter. We still see that the oxygen produces the lowest amount of our products, so that is obviously our limiting, meaning that is what limits the amount of product in our reaction. So thanks for watching. Have a good one.